So Netduino platform has been among us since 2010, and now in 2020 Wilderness Labs announces that this Netduino has been discontinued. So I make this video to say goodbye to our beloved Netduino. And if you don't know about the dev board and the software ecosystem, I will make a quick overview about the hardware and software in this video, okay? So stay with me. Hi everyone, Matheus Castello here, and if you don't know me, I am embedded software engineer and kernel Linux developer. And this is Micro Hobby, my YouTube channel where I like to share knowledge about embedded Linux, embedded systems, IoT and technology. So if you like this kind of content, don't forget to subscribe to the channel. Okay, so let's talk about Netduino. I have here a Netduino dev board. This is the Netduino 2 dev board. As you can see, at first this appears a lot with the Arduino. We had here the same form factor with the same pins, so we can use here the same shields from the Arduino on the Netduino. One of the cool things about Netduino is that we have here a much more powerful microcontroller. Here we have a firmware that can run C# on top of the .NET micro framework. Okay, so we will talk about the software later. Okay, let's first see the hardware details. So okay, let's take a look here on the microcontroller of our Netduino 2. Here we have an STM32F2. This guy is a 32-bit ARM Cortex M3 that runs at 120 MHz. Okay, this guy also exports 22 GPIOs, and we can use as SPI, I2C. We have 2 serial words, 4 PWMs, and 6 analog to digital channels. Embedded in it, we have also 192 kilobytes of flash and 60 kilobytes of SRAM. Okay, and for power our board, we have here a jack, a power jack that we can input from 7.5 volts to 9 volts, and this will be converted to 5 volts, and also we had another converter that will down this to 3.3 volts. Because our STM32F2 here works at 3.3 volts. Another thing is that all the GPIOs are 3.3 volts, but they are 5 volts tolerant. We also can power up the board here using the micro USB here. We have here an LED, the power LED, to show us that the board is turned on. We have here a button. This button can be used by the application, and also if you turn on the board with this button pressed, this will put the board on the bootloader mode, so we can flash a new firmware on the STM32 storage. Okay. Also we have here an LED. This LED we can use by the application too. Okay, so we saw a quick overview about the hardware, and now we will talk about the software stack. Okay, so we have these blocks on the software stack, on the Netduino software stack. I will share this information here and this image on my blog post. I will put the link on the description below. Okay, here we have the user code, the application block. This will be the C# code that you will write for your application, and this will use the .NET micro framework. Okay, here we call .NET micro framework because this is a subset of the .NET framework, because they need to take some things out of this .NET framework, because think about your hardware. We have an STM32F2 with only 192 kilobytes of storage, so we have to keep only what was necessary here. So because of this, we have a subset of .NET framework that is called .NET Micro Framework. Okay, these two guys here will be compiled to a intermediate language, and this intermediate language will be executed by the common language runtime inside the tiny common language runtime operation system. So here inside the tiny common language runtime operation system, we have the common language runtime that will receive the binary with the intermediate language, and you execute the application natively on the hardware. But for this, he counts on the help of more two abstraction layers: the platform abstraction layer that handle the memory, the IOs, and the timers, and the hardware abstraction layer. The hardware abstraction layer, that is the guy that knows the hardware. So if you need to put some GPIO as input or output, for example, the hardware abstraction layer that will have the implementation for this. Okay, so the hardware abstraction layer knows how to shift the registers and set up the things on the hardwares. Okay, so for some calls, the command language runtime do not need the platform abstraction layer. They can call directly the hardware abstraction layer. Okay, so let's see Netduino in action. I am here with the Visual Studio opened. We will write some C# code and Flash and run on our dev board. So here I installed the Visual Studio 2015 because this is the only version that the Netduino extension for Visual Studio works. Okay, so if you want to try it yet, you will to install the Visual Studio 2015. So with the Netduino extension, we have here the micro framework templates. I choose here the console application. Okay, and as you can see here, we have a default console application, a default .NET C# console application, a public class program, and a public static void main, where we will write our application. Okay, another thing is about the assemblies. Here we have to add the assembly references to Microsoft Spot, the Microsoft Spot native, the Net Micro Framework hardware, and the Secret Labs Net Micro Framework hardware Netduino. So we can use here this on our application. Okay, so here on the application we will blink an LED, and also we will handle some interrupts for our onboard button. So it's very cool. Is object oriented. Here we have the output port to instantiate and set a pin as output. Here I'm using the onboard LED. Here we have the interrupt port to instantiate and set a pin as interrupt for us. I'm using here the onboard button as reference to interrupt port. And look at this. With the interrupt port instantiate, we can use methods and events. Here I have the onInterrupt event, and I can add and delegate here. So when we press the button, this will run or delegate method. Here I have a while, a forever while. Okay, and this will change the LED electric status for us. So here I'm using the instantiate, the output port, referencing our onboard LED, and here we have these methods, the write and read. For example, we can read the electric status of a pin. So here I'm using only the write method to change for every 500 milliseconds the state of our LED to blink or LED. So to run this is very easy. With the board turned on, I will show here. I have the board here. Let's turn on the board. We can see the board is already blinking because I made a test here. So this is running the last program that I upload on the board. So let's upload this, but let's put some breakpoint here too. I will put a breakpoint here on this line, because when we press our button and this will breakpoint, this will stop to debug on this line. So let's run this. I will press the F5 button. This will run our application. First off, this will upload the binary, the intermediate language to our board. Okay, found the debugger, and this will begin to execute. You can see here the LED turn on and LED turn off prints that we have here. So the code is executing, the code is running on our dev board. We can see the LED blinking. Okay, so let's press here the button to see if our breakpoint will stop the execution. So yeah, very cool. We have here the breakpoint, and with the Visual Studio debug tools, we can, for example, mouse over the on the variables, and the interrupt comes from the port 27. That is the pin number of our onboard button, and the data is the electric state of this pin. So we have a high electric state. So let's continue the execution, and we can see we are again on our breakpoint, and we can see here the data now is 0 because we are using the interrupt mode here on the interrupt port. The interrupt mode interrupt edge buff. So this will call this interrupt for the press and for the release of the button. So you can see here the data, that is the electric status of our pin, that is a low state. Okay, so and now if I press again the F5, this will continue the execution of our application. Another cool thing is I'm running this on Visual Studio on debug mode. So if I press here the breakout or the pause button, this will pause exactly at the line that the application is at the moment. So I can press F10 to make a step-by-step debug. So you can see here the LED right to here, for example, on this line, making the calls on our firmware and changing the LED electric status. So it's it, guys. I hope you enjoyed this video. If you like it, don't forget to like the video, don't forget to subscribe to the channel. If you don't like, no problem, leave your dislike too. And I want to know your opinion about Netduino. What did you think of it being discontinued? So leave it here on the comments below your opinion. So yeah, it's time to say goodbye to Netduino platform and Netduino software ecosystem. So rest in peace, my friend.